Hey guys, so this is the last part of chapter 17, which is diversity and evolution of animals. So in part 4, which is what we're doing right now, we're going to talk about evolution of primates and human evolution. So we're going to get into that right now. Let me share my screen for the rest of chapter 17. We're starting on slide 79 for this, and like I said, this is the last part. So last time we were talking about chordates, and we left off talking about different types of mammals, how you had monotremes and how you had marsupials and then placental mammals. So humans are in a group of placental mammals called primates. Monkeys and apes are also primates. So with all of us, humans, monkeys, apes being placental primates, that means that we develop and all of our organ systems develop completely in utero, and then we're born and these organ systems are fully functional. So fossils and DNA tell the story of human evolution. If we're looking at the phylogeny of prosimians, monkeys, and then lesser apes, of course, lesser apes they're grouped in with apes, great apes, and then humans and their ancestors. We can see the general how we're related, evolutionarily how we're related. So a lot of people who don't believe in evolution, they say that humans didn't evolve from monkeys, and you are completely right. A chimpanzee is not a monkey, it's an ape, but also we didn't come from chimpanzees, okay? You can't evolve from something that is still living. So if you trace back the branch that humans are on, humans share a common ancestor with both bonobos and the common chimpanzees. So our cousin, the closest things, the closest organisms that are related to us that are alive today are bonobos and common chimpanzees. But we didn't come from bonobos or chimpanzees. We came from a common ancestor that was neither chimpanzee nor human. So opposable thumbs, long arms, upright movement are notable adaptations in one or more primate groups. So we're going to talk about these. We talked about how primates are placental mammals. That means they develop in utero. They evolved from small tree-dwelling, insect-eating mammals 55 million years ago, and they all share a set of characteristics. They have grasping hands that have opposable thumbs here and here, just like we do. They have sensitive fingers and toes with flat nails. Those flat nails just means that it's not like claws in some other mammals, like the cats, for instance, or bears. They're not claws. You've got close set eyes. Now, what that means, well, it's awesome to have close set eyes because instead of being able to have a wide field of vision, we can't see all around us. And even when we get out to our peripheral vision, our vision isn't great. But in front of us, what it means to have close set eyes is that we have these overlapping fields of vision. Okay, overlapping fields of vision mean that we have excellent depth perception, which is awesome for if you are going to be hunting or if you are going to be climbing in trees, if you're going to be doing any number of things, okay? Then they have large brains. So first we're going to talk about the prosimians, which are not monkeys, okay? Prosimians. Let me see. All right, so they're called the lorids. You've got lorises, podos, and lemurs. They are omnivorous, meaning that they're going to eat insects or fruits or plants, okay? They live in Madagascar, Africa, and southern Asia. Africa and southern Asia. Okay, so here's your loris, your ring-tailed lemur, and another prosimian that is not on here is called a tarsier. Now your tarsier, they are tree-dwelling carnivores. They're insectivores, so they eat insects. They are found only in Southeast Asia, and they're nocturnal, meaning that they hunt for these insects at night. And that's part of the reason why these eyeballs are so big is because they are nocturnal. So now we're moving on to the simians, and the simians are the monkeys, okay, the monkeys. So what sets monkeys apart from the prosimians, if you look back here at this phylogeny, which is just small, if you can see both of these New World monkeys and Old World monkeys, they're like bars, okay? Their branches are green. So if we trace those back and say, okay, what characteristic do they share that the prosimians did not have? Well, they have opposable thumbs. So that is a main difference between the simians and the prosimians. So you have these monkeys, specifically New World monkeys, which are of the Americas, so North and South America. They're arboreal with these prehensile tails that they use for swinging. So they're able to grasp things, objects with their tails and use them for swinging for their locomotion, as opposed to these Old World monkeys, which do not have these long prehensile tails, okay? Some are arboreal, but mostly they're going to be ground dwellers, okay? And again, these Old World monkeys, they're from Africa and Asia. Okay, so compared to monkeys, now we're going to look at, so we looked at prosimians, we looked at monkeys, now we're looking for everything from gibbons to humans are called the apes. The hominoids are the apes. Now, compared to monkeys, apes have all of these, have or don't have all of these characteristics. So apes lack tails, generally larger than the other primates. They rely more on vision than smell. They have a really keen sense of vision, but not as great of a sense of smell. Noses are short and broad rather than snout-like, again, because they don't rely on their scent for the things that they do day to day. They rely on their vision. They're capable of creating tools, using those tools, and using language. They have complex social lives and complex social hierarchies as well. Capable thinkers and problem solvers. So again, this is everything from the gibbons to humans are these hominoids or apes. All right, so all apes, their features, especially with locomotion, they are tree swinging, they run with their long arms and hands. Some of them have bipedalism, so especially in humans, but also some with chimpanzees. So chimpanzees can go back and forth from running with their long arms and hands to bipedalism. Their arms are shorter, leg bones are longer, and their leg bones are longer and stronger, because of this running on the ground or because of this bipedalism. Their foot bones are going to provide serious support for them, as well as their pelvic bones that support the weight of their body. They have their vertebrae add flexibility. The location of the foramen magnum is tucked underneath. So the foramen magnum, this is like the opening for your spinal cord, and yeah, like where your spinal cord is going to connect with your brainstem, okay? So in chimpanzees, it's a little bit further back, and that makes sense with the fact that they not only can be bipedal, but they also can run sort of just on their arms and legs, okay? Whereas humans, it's more difficult for us to run on our arms and legs. We're bipedal organisms, so ours is a little bit further up because that foramen magnum, it comes straight down because your neck comes straight down. All right, so the hominoids, let's see, the hominoids, these are the great apes. So you've got, oh, excuse me, no, we're still talking here. Hominoids, the apes. Hominids are the great apes. Couldn't read it. All right, so you've got your white-handed gibbons, your orangutans, your chimpanzees, your gorillas, and your humans. Now, their locomotion is different for each of these. Orangutans are fist walking or versus knuckle walking. That might seem different, but so I mean, it's just like when we were talking about Carolus Linnaeus and when we were talking about minute details of structures, the fact that one is fist walking and one is knuckle walking versus something like this hanging from trees and swinging from trees and things, these slight differences are going to really highlight the differences in these species. Okay, so locomotion is different. Got bipedalism in chimpanzees and in humans. Okay, so the apes all live in tropical regions of the old world, which remember was Asia and Africa. Large brains for their body size, long arms, as you can see, short legs, no tail. Some are tree dwellers, but most of them are going to be ground dwelling. So your diet, the shape of the skull and the shape of the teeth are going to be useful for detecting different types of hominoids. So for instance, your sagittal crest is how your jaw muscles are attached. Now, your sagittal crest, it's at the very top of your head, okay? Now, we have this sort of sloped plane, and it's much more abrupt in something like a chimpanzee skull. But anyway, that is where all of your jaw muscles are going to attach. Molars, we have molars and chimpanzees have molars. They're used for grinding, crushing, and mashing our food. Then the size and how much our jaws protrude, those are also differences in these hominoids. Yeah, it's going to tell us differences about our diets and differences about our locomotion and things like that. Similarities in bone structure reveal evolutionary relatedness. Molecular data also supports what we see here, where there are slight differences, like with the foramen magnum, but still, it's underneath the head of this chimpanzee. It's not on the back of the head like you would see with a lion, for instance. Similarly, our teeth are mostly the same. We have reduced teeth reduced in size compared to a chimpanzee, but really it's all very incredibly similar. So it's important to note, human species did not descend from chimpanzees, but rather humans and chimpanzees came from a common ancestor that was neither human nor chimpanzee. Okay. Molecular data reveals that shared genes of humans and chimpanzees are 96% identical. So they're incredibly close in terms of their relatedness, incredibly close. All right, emergence of humankind. Humans and chimpanzees diverged from a common ancestor 5 to 7 million years ago. Guys, in evolutionary time, that is like a drop in the bucket. That's not all that long ago. Homo sapiens, which is our current day species, evolved in a series of disordered steps. Now, this is cool. We're going to get into talking about human evolution now. What this means, disordered steps, is that there were many human species throughout the course of 200,000 years. There have been many species of humans. And it's these disordered steps because a lot of those human species existed at the same time in the past. So present day, we are the only species. Homo sapien is the only species of humans, but that didn't always actually used to be the case. So human features evolved at different rates, not in unison. So our lineage includes ancestors who walked upright, but they had small brains. So these hunter-gatherers that were max 4 feet tall, a lot of differences through the course of human evolution. All right, so here in this like darker brown, are we gonna say, are the Australopiths, okay? The Australopiths have this foramen magnum that is positioned downward, which suggests this upright walking. But if you look at all of these skulls, they are totally different, okay? They're totally different. I mean, they all look similar to modern day human, but they quite look different from each other, and they quite look different from modern day human as well. I mean, similarities and differences. Then you have Paranthropus. which had large teeth, protruding jaws, skulls with a sagittal crest. So a lot of these actually looked very similar to modern day chimpanzees, okay? And that's over here, these three, okay? Especially with this protruding jawline and those teeth. Then we get to the genus Homo, which is all of these like tan branches, all of these tan branches. As you can see, they've got these large brains and the jaws are not as protruding, right? So larger bodies, larger brains associated with stone tools, smaller teeth, lighter and less protruding jaws, larger brain cases, lighter brow ridges. The brow ridge is talking about this. So if you can see this, this is a really protruding brow line. This is a really protruding brow line, as opposed to this. We do not have very protruding brow lines. So if you look at this, the genus Homo, okay, we have a ton of fossil evidence for all of these different species of the Homo genus. Anywhere from present day to several 100,000 years ago. But if you look at this time scale, it goes from present to 600 million years ago, or excuse me, to 6 million years ago. Like I said, 6 million years ago, that's a drop in the bucket. We have fossil evidence for many of these. Trend shows rapid diversification followed by extinctions. Now, what's so interesting is that I told you that there were these, it wasn't in unison. The evolution, it sort of took a weird path. That is really interesting because a lot of these species actually live together. So when you had Australopithecus, like here, okay, Australopithecus discovering fire for the first time. Well, guess what? You have Paranthropus like coming over for a party and them like intermating. All of these species were actually able to mate with each other. And so when you think about like 23andMe, if you've heard from your friends or family members who've gotten it done, some people actually have DNA, Neanderthal DNA. Where is that? Homo neanderthalensis. That's because Homo sapiens mated with Homo neanderthalensis. Okay. So human evolution by natural selection looks a whole lot like other species. So with environmental changes, you had this shift from tree-dwelling organisms to upright walking, and that's because of these selective pressures. So human species originated in tropical forests of Africa. You had all of these environmental changes, all of these changes in climate, tropical forests replaced by open plains. That means likely what happened is that if you've got open plains now, upright bipedalism was probably a really advantageous trait to have, able to reach more, able to see further, etc. Here's your dispersal from Africa. So you've got ancestral humans in Africa migrating into Europe, migrating into Asia, migrating down to Australia, over this land bridge into Alaska, Canada, North America, the US, then down through Central America into South America. And you can see this more or less timeline. So we can estimate that humans were we actually have, okay, so this is 120,000 to 50,000 years ago. We actually have fossils from Ethiopia that were dated to 160,000 years ago for this old species, this old Homo species. All right, different selective pressures as these species of humans are moving into these different places and these different environmental landscapes, you have different environmental pressures. So skin pigmentation was heavier at places like the equator, okay, where sun is intense, and the pigmentation was lighter where it was less intense. Because if you think about it, melanin is a cost. Melanin is a metabolic cost to keep up in your body. And so if you didn't need it, if it wasn't going to provide any benefit to you, then you didn't need to make it. Brain size, development, and culture. So we know that culture was transmitted over generations through these different species of humans, okay? Via language, spoken and written language, via art, via tools, and things like that. So we've got three major stages of the evolution of culture. You've got nomadic hunter-gatherers who made tools and creative cave art 30,000 years ago. That is nothing, and that's nothing. Then we've got the development of agriculture, development of settlements between 10 and 15,000 years ago. And then the Industrial Revolution that came only 300 years ago, where we had the development of new technologies, which of course is changing everything about human evolution right now. We are changing, I think about like new technologies is changing modern medicine. We're changing who's surviving now. We're changing, like, we're changing a lot about people who are being able to survive and reproduce that normally, you know, in any other time period. Leah, what are you doing? What? That's weird. Okay. Anyway, all right, Industrial Revolution 300 years ago. Are you okay? Okay, consequences of human culture, because of course there are always consequences. So Homo sapiens, we have become a new pressure on Earth, and that's because we are changing landscapes quicker than many species are able to adapt. There is already in any habitat this struggles for survival, this struggle for resources, this struggle for habitat. So when we destroy habitats like this, we're just contributing to the struggle for survivorship. Now, the extinction rate in the 20th century was 50 times higher than the average extinction rate over the past 100,000 years. So we are greatly increasing the rate of extinction, much past just background extinction rate, which would happen even if we were not contributing the way that we are. An exploding human population threatens every ecosystem, because even so, we haven't, you know, we don't have people living in the oceans yet, but is what we're doing here having consequences in the oceans? Yes. All of the pollution of this exploding human population, yes. I mean, a lot of it is just getting dumped in our oceans. So we're affecting every single ecosystem on Earth. Now, Homo sapiens, you know that they are the only living hominin. These are your hominins. Actually, all of these, I'm so sorry, all of these are your hominins. Homo sapien is your only living hominin. Evolutionary relationships between discovered hominin fossils have been hypothesized. Of course, I told you we have fossils for the vast majority of these, but because we know a lot of these species were alive at the same time, it's really difficult to piece together these evolutionary relationships, because frankly, a lot of these species has DNA from other species in there. All right, guys, that's the end of chapter 17. So next week is our last week of classes, and we're going to do chapter 18, 19, and 20. And then beginning of next week, you'll have exam 3. We'll do 18, 19, 20. You'll have some quizzes, and some homework assignments. Then the following Monday, you'll have your final exam, and then you'll be done. So 3 more chapters. Hang in there. You have a good day.